This is the sound of a new superpower being born, not with armies marching across borders, not with treaties signed in quiet rooms, but with something far stranger, sand. Somewhere in the middle of the South China Sea, China has been quietly building entire man-made islands from scratch, placing a permanent chokehold on one of the most critical trade routes on the entire planet. And most people who glance at satellite photos of these places see nothing more than pale patches of sand sitting in open water. I see something else entirely. I see the single most ambitious engineering project attempted anywhere in the modern world. And once you understand the true scale of what's actually been built out there, you'll never look at those satellite images the same way again. This is the untold story of a trillion-dollar megaproject that is quietly reshaping global power. And by the end of this video, you'll understand exactly how a reef that completely vanishes underwater at high tide gets turned into a fully armed, self-sufficient fortress, and why the rest of the world has, so far, proven almost completely powerless to stop it. It all started here, on a scattering of half-submerged reefs most of the world had never heard of. For decades, China maintained only a token, largely symbolic presence on these contested outcroppings. But sometime in the early 2000s, a secret, extraordinarily audacious plan was quietly set into motion behind closed doors. The objective was as simple as it was staggering in ambition: permanent unsinkable aircraft carriers, built not from steel hulls floating on the ocean, but from solid, engineered land, rising directly out of the seafloor itself. The chosen location was the Spratly Islands, a strategically vital crossroads of open ocean claimed, in whole or in part, by half a dozen different nations, each with their own competing interests in these waters. The first problem engineers faced wasn't political at all. It was purely geological. You cannot simply build a permanent military installation on loose, shifting coral rubble sitting in open ocean. There's no solid bedrock beneath it, nothing anchoring it in place, and everything about that environment actively wants to wash away with the very next storm that rolls through. The solution arrived by sea in the form of an entire fleet of colossal dredging vessels, some of them genuinely the size of football fields, representing what is widely considered the largest and most technologically advanced dredging fleet ever assembled by any single nation, built by China specifically, for this exact purpose. At the heart of the entire operation sat something called a cutter suction dredger, a vessel that functions essentially like a floating blender combined with an industrial vacuum cleaner, its entire job simply to tear apart the seabed below and suck the resulting material straight up to the surface. These machines could process tens of thousands of tons of seabed material every single hour. They weren't merely digging small trenches. They were effectively relocating entire underwater mountains from the bottom of the sea directly up into open air. That extracted material was then pumped, sometimes for miles across open water, directly to its intended destination, where it would form the literal foundation of brand new land rising out of nothing. The birth of these islands was violent, genuinely messy, and almost unbelievably fast, hour by hour. The original reef quietly disappeared beneath the surface while a completely new island rose in its place. But that newly formed land was, in its earliest state, completely unstable, essentially nothing more than an enormous, waterlogged pile of loose sand that the very next serious storm could easily wash straight back out to sea. So, before engineers dared build anything permanent on top of it, they first constructed a shield, a full perimeter wall specifically designed to protect what had already become a multi-billion-dollar investment sitting exposed in open ocean. Massive hollow caissons were floated into position, then deliberately filled with sand and allowed to sink, forming an interlocking, solid wall around the perimeter of each new island. Precision mattered enormously at this stage, because this perimeter wall effectively formed the entire foundation of the island's long-term physical defense against the ocean itself. Kilometer by kilometer, that fragile pile of loose sand was gradually encased in solid concrete, transforming an unstable sandbar into something engineers could actually build upon with confidence. From there, engineers had to physically squeeze the trapped water out of the new land entirely, a process known as compaction, which gradually turned that loose, waterlogged slurries into genuinely stable ground capable of supporting serious, permanent construction. Constant testing throughout this phase ensured the compacted ground could reliably support everything that was about to be built on top of it. And with the underlying land now finally secure, the second wave of construction began, arguably the largest active construction project happening anywhere on Earth at that time. The very first priority was a runway stretching 3,000 meters long, more than sufficient length to accommodate essentially any aircraft in China's entire military arsenal. A runway of this scale isn't simply a slab of flat pavement, it's actually an incredibly complex layer cake of specifically engineered materials, purpose-built to absorb the repeated violent impact of a 200-ton military aircraft touching down at speeds approaching 150 miles per hour. Remarkably, engineers even used the very same dredged sand extracted from the seabed to manufacture their own concrete on-site, deliberately minimizing their dependence on vulnerable outside supply lines running across open ocean. This entire construction effort ran as a genuinely non-stop 24-hour operation, representing modern engineering pushed to its absolute practical limits. The finished result contained no visible joints, no structural weak points, simply one continuous, perfectly reinforced slab of concrete stretching the full length of the runway. Hundreds of individual workers toiled continuously in brutal tropical heat, gradually transforming what had recently been nothing more than a sandbar into a genuine strategic military asset. In a matter of only a few months, something that sounded almost physically impossible was actually achieved. The engineering tolerances involved here are genuinely staggering. The entire 3-kilometer runway was completed perfectly flat, with a total surface deviation measuring less than a single centimeter across its entire length. At this point, the island had stopped being simply an island. It had officially become a functioning military airfield. But an airfield by itself remains dangerously vulnerable, and the aircraft eventually stationed there would need real physical protection. Engineers began constructing hardened aircraft shelters, purpose-built structures specifically designed to withstand a direct missile strike without losing the aircraft sheltered inside. Each individual hangar effectively functions as its own fortress, nested within the larger fortress of the island itself, built with layer upon layer of reinforced protection. Once the heavy doors of one of these shelters swing shut, the aircraft parked inside becomes remarkably safe from almost any conventional threat imaginable. Engineers ultimately built enough of these hardened shelters to comfortably house an entire squadron of fighter jets simultaneously. But an island this heavily fortified still needed something else entirely: a functioning brain, a dedicated command and control center capable of processing everything happening around it. Yet even the most sophisticated command center remains essentially useless if it's operating blind. So to properly control the surrounding airspace, the island needed genuine eyes and ears capable of piercing far beyond the visible horizon. That distinctive white sphere visible in satellite photos, often nicknamed a golf ball by observers, is actually a radome, a protective housing specifically designed to shield a sophisticated radar system from harsh tropical weather while still allowing its electronic signals to pass through completely unobstructed. Once fully operational, a single one of these radar domes provides continuous, sweeping surveillance coverage of every ship and aircraft moving anywhere within a massive 400-mile radius. And engineers didn't stop there. They also installed specialized high-frequency radar arrays specifically engineered to bend radio signals in ways that effectively allow them to see targets sitting beyond the natural curvature of the Earth itself. All of that continuously gathered surveillance data would be genuinely useless, however, without the underlying infrastructure needed to process and distribute it in real time. Extensive fiber optic cable networks were laid to connect every single system across the island into one unified network. Buried beneath the surface sits a fully climate-controlled, state-of-the-art data center, deliberately buried deep enough to realistically survive a direct military assault. With little more than the flick of a switch, massive volumes of raw surveillance data began flowing continuously through this newly completed network, and the island, in a very real sense, finally woke up. But simply watching potential adversaries from a distance was never going to be enough to actually secure this territory long-term. This island fortress needed real teeth as well. Engineers began installing a vertical launch missile system, the exact same type of weapons platform used aboard China's most advanced modern naval destroyers. Hidden beneath these unassuming concrete hatches sits a genuinely lethal arsenal, missiles specifically designed to knock enemy aircraft directly out of the sky, or strike enemy warships from hundreds of miles away, long before those vessels would ever visually spot the island itself. To an untrained observer, it might look like nothing more than an unremarkable patch of concrete. In reality, it functions as an entirely invisible arsenal, fully armed and ready to fire at a moment's notice. An airfield alone represents only part of the strategic equation, however, because becoming a genuinely comprehensive strategic hub also required building a proper deep water port. Engineers needed a harbor deep enough and structurally strong enough to accommodate the heaviest vessels in the entire Chinese naval fleet, far beyond simple supply barges alone. This meant constructing a facility specifically capable of docking full-sized destroyers, heavy frigates, and eventually, potentially, even full-sized aircraft carriers themselves. With that single addition, engineers had effectively connected sea power and air power together in one unified location, which represented the true underlying strategic goal driving this entire project from the very beginning. Yet even an outpost this heavily armed simply cannot survive indefinitely on weapons systems alone. To realistically maintain a permanent garrison of military personnel, the island had to become genuinely self-sufficient in every practical sense. Engineers built out the essential infrastructure of an entire small city: permanent housing, expansive recreational facilities, and even high-yield, fully climate-controlled indoor farms capable of producing fresh food locally. Freshwater quickly emerged as perhaps the single most critical resource on the entire island. A dedicated desalination plant was constructed specifically capable of producing several hundred tons of clean drinking water every single day. To power the entire operation reliably, massive fields of solar panel arrays were installed to harvest the intense tropical sunlight beating down on the islands year-round, dramatically reducing the garrison's overall dependence on vulnerable fuel shipments arriving by sea. By combining solar power, heavy-duty wind turbines, and substantial backup diesel reserves, engineers created a remarkably resilient hybrid electrical grid, specifically designed to ensure the island's command center would never lose power under any realistic circumstances. Even seemingly minor additions, like a freshly painted basketball court sitting incongruously in the tropical sun, actually served a genuinely important purpose. These small touches of ordinary daily life proved essential for maintaining morale among troops stationed in such extreme remote isolation. This point marked a genuine tipping moment for the entire project. The sprawling construction site had visibly transformed from what had initially been chaotic, ongoing construction into a highly organized, fully functioning military settlement. Every single element of the island was meticulously planned out, almost like laying out the grid of an actual small town. Dedicated parking areas were built specifically for transport aircraft, with the entire tarmac carefully divided and mapped into highly specific zones for different aircraft types, guaranteeing maximum logistical efficiency during any emergency scramble situation. Engineers built an entire hydrant refueling system directly into the airfield itself, allowing any aircraft to be fully refueled within minutes without ever needing a separate fuel truck to physically arrive. Hidden directly beneath the runway surface sits a massive underground network of fuel storage depots, capable of holding millions of gallons of highly volatile jet fuel in reserve. However, out in the middle of the open ocean, the single greatest ongoing enemy often turned out to be nothing more dramatic than the weather itself. Controlling the sheer volume of tropical rainfall dumped onto these islands became a constant, genuinely demanding engineering battle. A single powerful typhoon can realistically dump an entire foot of rain across the island in just a few hours, and without a properly engineered drainage system, the entire finished airfield would simply flood and become completely useless almost overnight. To coordinate the increasingly complex daily ballet of military air traffic moving in and out, engineers erected a towering air traffic control tower, standing highly visible against the otherwise flat, low-lying landscape of the island. From the fortified safety of that tower, specialized air traffic technicians would soon begin directly guiding heavy military aircraft in and out, maintaining direct visual line-of-sight communication with every approaching plane. Meanwhile, construction crews rapidly finished building out massive barracks complexes nearby, substantial reinforced concrete structures specifically designed to house the hundreds and eventually thousands of incoming military personnel. The interior spaces inside these barracks remained deliberately stark, purely functional, and genuinely Spartan in design. Feeding an entire permanent garrison of this size ultimately required outfitting industrial-scale kitchen facilities, specifically capable of reliably producing thousands of individual meals every single day without fail. Engineers also established a comprehensive on-site medical wing, fully equipped to handle everything ranging from routine everyday illnesses all the way up to severe combat trauma, all without ever needing to evacuate patients back to the mainland. As one engineer involved in the broader effort reportedly put it, this entire process functioned as a genuinely iterative one. You get the absolutely critical infrastructure operational first, then you steadily build outward from that secure foundation. With this runway now fully cured and structurally sound, the rigorous operational testing phase finally began in earnest. Engineers started cautiously, launching sophisticated unmanned aerial systems specifically to probe the surrounding airspace before risking any manned aircraft. These drones flew relentless, repetitive patterns directly over the island, systematically calibrating the newly installed radar systems, and simultaneously establishing secure, reliable communication links across the entire base. Once every underlying system had been thoroughly proven reliable, the true milestone moment finally arrived. The very first manned aircraft flight to actually land on the island. It wasn't a sleek, sophisticated fighter jet making that historic first landing, but rather a heavy, dependable military transport workhorse instead. As the aircraft's rear ramp slowly lowered and the very first official garrison of troops marched confidently onto the tarmac, a genuine piece of modern history was quietly made. A massive, permanent aerial supply, bridged to this entirely artificial island, now stood wide open for the very first time. This single development fundamentally changed everything about the island's long-term viability, because the garrison was no longer entirely dependent on slow sea transport alone for critical supplies and rotating personnel. With the interior infrastructure of the island now genuinely secure, military engineers immediately shifted their intense focus outward, working to fortify the fragile physical perimeter of the entire island against external threats. They installed an incredibly dense, fully integrated surveillance network, feeding a completely seamless, uninterrupted 360-degree view of the surrounding waters directly back to the island's central command center. Engineers also began installing close-in weapon systems, commonly referred to by the acronym CIWS, representing the absolute final line of defense against incoming threats, a genuinely terrifying, radar-guided, fully automated cannon system capable of firing an astonishing 4,500 rounds every single minute. These specialized weapons were specifically engineered to obliterate low-flying, sea-skimming anti-ship missiles, or fast-moving swarm attacks launched from small boats, before any such threat could ever realistically reach the island's protective concrete perimeter wall. In essence, engineers had constructed a fully layered defensive system, long-range missile batteries, medium-range gun emplacements, and short-range automated cannons, all working together in coordinated layers. Engineers had genuinely thought through nearly every conceivable threat scenario in advance. Then, finally, the true operational muscle of the Chinese military formally arrived at the island. A heavy naval frigate slowly glided into the newly completed harbor for the very first time. As sailors aboard the vessel carefully tied off the ship's heavy mooring lines, the island's deep-water pier, which had begun its existence as nothing more than a flat, empty slab of concrete sitting on an artificial sandbank, finally fulfilled its intended purpose. Chinese naval forces could now realistically resupply and rearm their warships directly at this remote outpost sitting in the middle of the open ocean, effectively extending their operational range and sustained patrol times indefinitely into the surrounding waters. It amounted to a flawless, genuinely unsettling display of coordinated modern military logistics, a seamless integration of land power, sea power, and air power all operating together as a single unified strategic system. In the project's final construction stages, extensive landscaping efforts were deliberately launched across the island, a conscious, calculated attempt to soften the otherwise harsh, purely functional concrete environment surrounding the base. In a very real sense, engineers were deliberately transforming what had begun as a purely military installation into something resembling a genuine small town. This entire effort was fundamentally about establishing long-term, unmistakable permanency. When soldiers stationed on the island formally saluted during an official flag-raising ceremony, that moment became far more than simple military ritual. It functioned as a highly calculated, deliberately symbolic act, asserting absolute, unquestionable sovereignty over the territory. From neatly maintained sports fields to carefully installed streetlights lining the island's internal roads, unmistakable signs of a permanent, unyielding, genuinely long-term military deployment are now visibly etched into virtually every corner of the completed island. To ensure the base was never realistically cut off from the mainland, engineers also erected a sprawling farm of satellite communication dishes, guaranteeing an unbreakable high-bandwidth communications lifeline stretching all the way back to mainland China regardless of local conditions. In less than 2 frantic years of continuous construction, China had genuinely pulled off something that had once sounded almost impossible. They had, in the most literal sense possible, manufactured an entirely permanent, heavily armed strategic reality out of nothing more than open ocean and dredged sand. Consider Fiery Cross Reef, specifically as one striking example. What had once been nothing more than a tiny, jagged rock formation barely breaking the surface of the waves has since become the sprawling crown jewel among this entire chain of island fortresses. Positioned correctly alongside its sister installations, this arrangement creates deliberately overlapping fields of fire and overlapping sensor coverage across the entire Spratly Island chain simultaneously. With these 3 strategic points now fully connected and operational, the surrounding trap effectively springs shut. Almost nothing can realistically move through this entire critical sector of the South China Sea anymore without Beijing tracking its exact position in real time. Then, finally, the true apex predators of this new system arrive to formally claim their new territory. This represents the stark new operational reality now defining the entire region. Chinese Coast Guard vessels and naval warships now aggressively patrol and effectively dominate these contested waters, enforcing sweeping territorial claims backed directly by steel and firepower. In the end, they didn't simply build an island out in the middle of nowhere. They built an entire permanent platform specifically engineered for long-term power projection across an enormous stretch of ocean. From the reinforced concrete runways of these artificial islands, China now possesses the genuine demonstrated capability to project overwhelming military power across the entirety of the Southeast Asian region, essentially at will. Before this island building program began, China's naval and air fleet operated under genuinely limited operational range in these contested waters. Now, backed by this entire interconnected chain of forward supply bases, their effective operational reach has become functionally global in scope. Step back for a moment and really consider what a project of this magnitude actually demanded from the people who built it, because the individual facts, the runway tolerances, the dredging, volumes, the missile systems, tend to blur together into an abstract list of impressive numbers unless you force yourself to picture the actual human effort sitting behind every single one of them. Somewhere out on those reefs, for months on end, engineers were living and working on land that quite literally did not exist a year earlier, standing on ground that had been sucked up from the bottom of the ocean floor and pumped into place beneath their own feet. Every single decision made during that early compaction phase carried enormous weight because get the ground preparation wrong, even slightly, and every structure built on top of it in the years that followed would inherit that same underlying instability, a slow-motion failure waiting patiently beneath the surface for the next serious typhoon to expose it. That's part of why the caisson walls and the compaction testing receive so much attention in any honest account of how these islands actually came together, because the dramatic elements, the runways, the missile systems, the radar domes, only work at all if the unglamorous foundational work underneath them was executed with genuine precision first. Consider, too, the sheer logistical challenge of supplying a project like this in its earliest years, before the runway existed, before the deepwater harbor was operational, when every single ounce of construction material, every worker, every piece of heavy machinery had to arrive by slow, vulnerable sea transport across open ocean, exposed the entire way to weather, current, and the simple physical remoteness of operating hundreds of miles from the nearest reliable port. That vulnerability is exactly why the eventual air bridge, that first heavy transport aircraft landing on a runway that had been open ocean just months earlier, represented such a genuine turning point in the entire project's viability, because from that moment forward, the island stopped being entirely dependent on the whims of the sea for its own survival. And it's worth pausing on the sheer redundancy engineered into these islands once you look closely at the finished result. Solar arrays paired with wind turbines paired with backup diesel reserves for power. Desalination plants paired with rainwater capture systems for fresh water. Underground fuel depots paired with hydrant refueling systems for aircraft turnaround. Layered defense systems stacked from long-range missiles down to short-range automated cannons. None of that redundancy happens by accident, and none of it happens cheaply. It reflects a deliberate, almost obsessive planning philosophy built around a single core assumption, that these islands might one day need to function completely independently, cut off from resupply for extended periods of time, and every single system on the island had to be engineered with that worst-case scenario firmly in mind from the very beginning. It's also worth understanding just how quickly the strategic character of this entire region shifted once these islands became fully operational. Ships and aircraft that once moved through these waters with relative anonymity now do so under the constant overlapping gaze of radar systems capable of tracking targets from 400 miles away, feeding into command centers built specifically to fuse that data into a single coherent picture of everything moving across an enormous stretch of open ocean. Fishing vessels, commercial cargo ships, foreign naval patrols, all of it now passes through a sector of ocean that, less than 2 decades ago, contained nothing more than scattered reefs occasionally visible above the waterline at low tide. The transformation didn't simply add new territory to a map, it fundamentally altered who controls the flow of information, and ultimately the flow of commerce and military movement across one of the busiest, most economically vital waterways on the entire planet. And perhaps the most striking part of the entire story is simply the timeline itself. Traditional military infrastructure of this scale, runways, hardened shelters, deepwater ports, permanent garrisons, typically takes the better part of a decade or more to plan, fund, and physically construct through conventional government processes. China compressed that entire timeline down to a matter of a few frantic years by essentially building the land itself first, then layering increasingly sophisticated infrastructure on top of that freshly created foundation in rapid, overlapping phases, rather than waiting for each stage to fully complete before beginning the next. That approach carried genuine engineering risk, building critical infrastructure on land that was, in geological terms, barely a few months old, but it also allowed the entire project to move at a pace that conventional military construction almost never achieves anywhere else in the world. There's also a quieter, more human dimension to this story that rarely makes it into the satellite photos or the strategic analyses. The thousands of individual workers and eventual military personnel who actually lived through this transformation day by day, watching a patch of open ocean slowly become a runway, then an airfield, then a fortified base, then finally something resembling an actual small town complete with sports fields and streetlights. For the people stationed there permanently, isolation was never simply an abstract strategic consideration. It was the daily reality of living hundreds of miles from the nearest city, dependent entirely on infrastructure that, in geological terms, was barely older than they were. Consider, finally, just how differently this story reads. Once you strip away the abstraction of maps and strategic briefings and simply focus on the physical sequence of events, empty ocean, then dredged sand, then compacted land, then concrete, then runway, then radar, then missiles, then people, then permanence. Each single step depended entirely, completely, and irreversibly on the one immediately before it, and removing even a single link. Anywhere in that long chain would have collapsed the entire 6-year timeline. This started as nothing more than a concept sketched out on paper somewhere inside a government planning office. And in this video, we've broken down exactly how that concept was brought to life using nothing but concrete, steel, dredged sand, and an almost unbelievable level of coordinated engineering ambition. If you want to see the engineering story behind more of the world's most audacious, seemingly impossible megaprojects, hit that subscribe button.